Okay, for the first problem here, we want to compute f prime at 2. Right, f prime at 2 is how we read this notation. That means find the derivative at the point where x or a is equal to 2. Right, the derivative tells us the slope of the tangent line, for instance. That's what this problem, we're going to use the derivative to tell us the slope. Okay, so the first definition, right here, right, we want to compute f prime of 2. That means we're going to use here that a is equal to 2. And so we need to set this up. So f prime of 2 equal the limit h approaches 0 of f of 2 plus h. That means I need to evaluate my function at the value 2 plus h minus f of 2 all over h. So now I'm going to use the definition of the function here. So plug 2 plus h in, I get 2 plus h squared plus 2 times 2 plus h minus 3. Right. So that whole business corresponds to f of 2 plus h minus f of 2 So f of 2, I can just substitute into my function the value 2, and if I do that, you go back and do it, I'll get to 5. So we're going to replace this with 5 divided by h. Alright, as h goes to 0, I've got a problem here. I'm dividing by 0, and upstairs, if you check carefully, you also have a 0. So I need to factor or expand or use one of my tricks here to get rid of this h in the denominator. Well, the trick to use here is to expand. So we have the limit as h goes to 0. Let's see, if I FOIL out this term, I get 4 plus 4h plus h squared plus 4 plus 2h, distributing the 2 in that second term, minus 3 minus 5 divided by h. Okay, the minus 5 here, let's zoom out here a little bit so we can see where all these terms came from. So the minus 3 is here, the minus 5. Right. So let's see, 4 plus 4 is 8, so 4 plus 4 is 8, and minus 3 minus 5 is negative 8. So all that cancels, and if we look carefully here, every term that remains has an h in it. So cleaning up, we have 6h plus h squared divided by h. Now we can factor an h out of the top. Now as h approaches 0, we can just use direct substitution to see that this limit is 6. Now we're going to do it again using the second definition. Okay, the second definition is here. In this case, we want to put in f prime of a. We're going to use 2 for a again. There should be in here an equal sign. So we have f prime at 2 as the limit as x approaches a, so x approaches 2, of f of x minus f of 2 over x minus 2. So f of x, well, that's just my function evaluated x, which I've already got there. So x squared plus 2x minus 3, and then minus f of 2. I know from before when I plug 2 into my function here, I get 5. So I have minus 5, all divided by x minus 2. Now as x approaches 2, I've got a 0 in the denominator. If you look carefully, there's a 0 in the numerator as well. So I need to factor and cancel. Factor the numerator. And now as x approaches 2, x plus 4 approaches 6. Again, just use direct substitution. All right. We could use either definition here. I think on the version of the worksheet that I provided in class, it said use the first definition. What we're going to do here is repeat what we did in the first part, so up here. But now we're not going to specify the value of a. So when we're done here, we're going to have a formula that tells us the derivative, tells us the slope of the tangent line for an unspecified value of a. And then we can use that formula later to plug in a particular value of a. So according to our definition, notice I'm not specifying a number for a here. I'm just leaving it, so I have f of a plus h. This is just a little more complicated than when we worked it through with a equals 2, but not much so. I evaluate my function a plus h, so I have a plus h squared minus plus 2 times a plus h minus 3 minus the value at f of a, so a squared plus 2a minus 3. Right, now notice here I've put parentheses around the f of a term, so I put parentheses around this whole piece here so that I can correctly distribute this minus sign. We're going to expand this and collect terms. Now the algebra is similar. If I do things correctly, everything that does not involve an h in the numerator had better cancel. Right, because I have to have a common h in the numerator to cancel the bad h in the denominator. So a squared minus a squared. 2a minus 2a. Negative 3 plus 3. Now everything that remains has at least one factor of h in it, which can now be factored out. Notice also here that I have 2ah plus 2h. We'll just leave it like that. Right, I'm going to factor out the h from those three remaining terms. So we get h times 2a plus h plus 2. Divided by h, cancel the h's, and now by direct substitution I can plug in h equals 0 and I get 2a plus 2. Now notice here if I made a equals 2 as we did in the first problem, that I'd have 2 times 2 plus 2 is 6. Right, so this result is in good agreement with the previous answers. Right, the advantage to this result is that if I want to calculate the slope at some other value, I can just do that by changing the value of a. So f prime at a is equal to 2a plus 2. Therefore, f prime at minus 5 is 2 times minus 5 plus 2 is negative 8. Okay. Now we're going to use our slope result above to remind ourselves about a tangent line. We want the equation of a tangent line. I'm not going to try and graph this accurately, but we have some function at x equals 2. We have determined from above that the slope of the tangent line is 6. Right? To find the equation of a line, I need the slope and a point. So I need to find the coordinates of this point on the graph. In order to do that, all right, I'm going to go back and use my original function written above and evaluate it at x equals 2 to get the y value, y coordinate of this point. So y is equal to f of 2 squared. Right, our function, let's review, is way up at the top here. X squared plus 2x minus 3. So I'm substituting 2 for x. So x squared plus 2x minus 3 is 5. So the coordinates of the point on the curve where we want the tangent line are 2, 5. So this is also a point on the line. Right, and I'm going to start with my point slope form. Right. The coordinates of my point are 2, 5, so the 2 goes there, the 5 goes there, and the slope, which we calculated above, 6, goes there. Adding 5 to both sides, I see that the equation in slope-intercept form is 2x plus 1.